All right, we're going to start with a power move. Welcome to the class. Whew. All right, my name is Roger Whitesell. It is January 13th, 2020, and today we're going to do some math. So let me share my screen. I am going to share the sound as well. So that would mean that I would like to play a little music for you. So let's see how that works. I'm going to play the Wear Sunscreen one. Media.
Long-term benefits of sunscreen have been proved by scientists, whereas the rest of my advice has no basis more reliable than my own meandering experience. I will dispense this advice now. Enjoy the power. Oh, never mind. You will not understand the power and beauty of your youth until they've faded. But trust me, in 20 years, you look back at photos of yourself and recall in a way fast now how much you really looked. You are not as fat as you imagine. Don't worry about the future, or worry, but know that worrying is as effective as trying to solve an algebra equation by chewing bubblegum. The real troubles in your life are apt to be things that never crossed your worried mind, the kind that blindsides you at 4 p.m. on some idle Tuesday. Do one thing every day that scares you. Sing. Don't be reckless with other people's hearts. Don't put up with people who are reckless with yours. Floss. Don't waste your time on jealousy. Sometimes you're ahead, sometimes you're behind. The race is long. And in the end...
All right, here we go. So back in this would have been in 1969. 1969, I remember watching the moon landing, and everybody talked about how the astronauts could jump so far, and it had to do with the fact that the force of gravity was much less on the moon. So I thought it might be interesting if we just kind of made a calculation of what the difference would be. So what I'm saying here is that the force of gravity of a sphere is proportional to its volume. The Earth has a radius of 4,000 miles. The moon has a radius of about 1,000 miles. If you weigh 120 pounds on the Earth, how much would you weigh on the moon? All right, that means if we go with our little ISME, we can tell just from the beginning here that this is probably going to involve volume. So now we're going to set up the equation. So that means we're going to do a couple of volumes. So we're going to say the volume of the moon is going to be equal to 4 birds times pi times r cubed. So we're given what the radius is. So this is just going to be 4/3 pi times 1,000 raised to the, I think we'll just do it this way, 1,000 raised to the third power. All right, easy enough. So that means that the volume is going to be equal to 4/3 times pi times 1,000 y to the x 3 equals 4.18 times 10 to the 9th. Okay, so that's going to be in miles cubed. All right. So now we want to do the volume of the Earth. This is going to be 4/3 times pi let's just put in the 3.14 and then this is going to be 4,000 cubed. So that's going to give us a volume of, this is the Earth. It's going to give us 4. Now, so all we have to do is plug in these numbers. So 4/3 times 3.14 times 4/3 times 3.14 times 4,000. So this is going to be 2.68 times 10 to the 11th. All right, so now what we're going to look at is the fact that these, we said that the gravity was equivalent, the force of gravity was equivalent to, it's proportional to the volume. So if I put the volume of the Earth over the volume of the Moon, that's going to equal the weight on the Earth by the weight on the moon. So we're just setting up a proportion. Okay, let's plug in what we know. We know that the volume of the Earth is 2.68 times 10 to the 11th. We're going to divide the volume of the moon was 1. And that whole thing is going to be equal to the weight on the Earth, which we said was 120, divided by the weight on the moon. So what we're going to do at this point is cross multiply. So what we're going to end up with is the weight on the moon times 2.68 equals 120. All right, your poor little brain is just not working that fast. We got to work faster, faster, faster. All right, we're going to try our little pad here and see if we can get any faster. So let's see. There we go. All right, so we want to get this by itself. So we're going to divide both sides. Whew. Well, that's not much of an improvement, but it does give us what we need here. So we're going to say so let's see what it's going to be. 120 times 4.18 times 10 to the 9th divided by 2.68 divided by 10, what are the x 11 equals? Well, that does not look right, so we better shut her down here.